Okay, y'all. I said we were going to work some problems, but I forgot to tell you something very important on this first page. So if you'll go back there, we need to talk about a pattern that parabolas follow. And it's the 1, 3, 5, 7 pattern. And if you'll write this down, I'll explain what I mean. So when we're graphing a parabola, the first thing we do is find the vertex. On the parent point, the vertex is easy, it's 0, 0. But if we don't have a parent parabola, we're going to use this formula right here, x equals negative b over 2a, to find the vertex. Then once we find the vertex, we're going to do our pattern, 1, 3, 5, and 7. We write down those numbers, 1, 3, 5, and 7, and we times it by whatever the a value is. Now in my parent, the a value is an understood 1. So 1 times 1 is 1, 1 times 3 is 3, 1 times 5 is 5, 1 times 7 is 7. So 1, 3, 5, and 7 are our numbers we're going to use. So we graph our vertex. Now here's where it gets fun. We go up 1 and over 1 in each direction. Then from those points we go up 3 and over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. Now the next one we would go up 5. 1, 2, 3, 4, 5 and over 1. So mine actually needs to kind of go out a little bit. And it would go, but that side's not so bad. Okay, so the pattern 1, 3, 5, 7. Now most of the time on your graphs you're only going to have room for the 1, the 3, and the 5. But if you have a big graph and you have room for 7, then it would be 1, 3, 5, 7, 9, 11, etc. So let's work some. Turn with me to page 2 in your packet. Uh-oh. Sorry about that. My page 2 was laid somewhere else. So here's your page 2. Now, let's read the instructions. Sketch the graph of each function. Determine if the function has a maximum or a minimum and find that max or min value. State the domain and range of each function. Guys, these are super important problems and you're going to do them over and over and over. So let's make sure we learn them. Okay? I'm going to start with problem 3. And then I'm going to do problem 6. And I'm going to ask you to turn off your video and try 4 and 5 for me. Okay, starting with problem 3. Let me move it down here so I can see it and write. The first thing I've got to do is find the x of the vertex, which is x equals negative b over 2a. So I look over here, a is negative 1/2, b is negative 4, c is negative 10. So it says negative b, so that's negative 4. That's going to make it a positive 4. 2a, 2 times a is negative 1/2. So now let's work that math out. Negative 4 makes positive 4. 2 times negative 1/2, a positive times a negative is a negative. 2 times a half is 1. 4 divided by 1 is 4. I've made a mistake somewhere. There's my mistake. 2 times negative 1/2 is negative 1. 4 divided by negative 1 is negative 4. You know, even your old math teacher makes mistakes. All right. Were you wondering how I knew I made a mistake? If x is positive 4, it's not on the graph. These little graphs kind of help you know where your answer needs to be. They're a little bit of a cheat for you. So x equals negative 4. Okay, let's go through it again. Negative b over 2a, that's the negative. Here's the b. b's negative 4. Negative 4 makes positive 4. 2a, 2 times negative 1/2 is negative 1. 4 divided by negative 1 is negative 4. Now we've got to find the y. So y equals We're going to go back to this equation and we're going to plug in the value of x everywhere we see it. So negative 1/2 times negative 4 squared. And guys, I'm just going to tell you, if you were going to punch these in on your calculator, you're going to have to put in these parentheses, or otherwise you will get sign errors all over the place. So negative 1/2 parenthesis negative 4 squared minus 4 parenthesis minus 4 minus 10. So let's work it out. Order of operations says we do parentheses and exponents first. So negative 4 squared is positive 16. Positive 16 times negative 1/2 is negative 8. Negative 4 squared is 16, positive. Negative times negative is positive. Positive 16 times negative 1/2 is negative 8. Negative 4 times negative 4 is positive 16 minus 10. Negative 8 plus 16 is positive 8. 8 minus 10 is negative 2. So my vertex, and I'm going to put a V, and that's how I would like you to write it, is negative 4, negative 2. So come over here to the graph, to negative 4, negative 2, and put me a dot at negative 4, negative 2. Okay? Now, I've got my x and my y, the vertex, so I'm going to write my 1, 3, 5. And you don't have to write 7 because you're not going to have room to get it. I have to times 1, 3, 5 by the a value. The a value is negative 1/2. 1 times negative 1/2, and I'm not going to have room to write that. Alright guys, let's write it smaller. 1, 3, 5, and I'll write it up here, times negative 1/2. 1 times negative 1/2 is negative 1/2. 3 times negative 1/2 is negative 3/2. 5 times negative 1/2 is negative 5/2. Okay? So come to my vertex, which I kind of made big and sloppy. Let's make it a little smaller. Come to my vertex at negative 4, negative 2. Negative 1/2 means go down a half. Well guys, you can kind of see on yours, there's kind of a point there where it's a half. Go down a half and over 1, go down a half and back up 1. That gives me the next 2 points. Now I have to go down 3 halves, so I'm going to count by halves. I start at the 2 points I just made, 1/2, 2 halves, 3 halves, over 1 whole, 1/2, 2 halves, 3 halves, over 1 whole. Okay. Now I'd really like you to make the next point, even if you don't have room to get there. I've got to go down 5 halves, so start at this point, 1/2, 2 halves, 3 halves, 4 halves. I'm going to have to go another half, which would be about right there, over 1, 1/2, 2 halves, 3 halves, 4 halves, 5 halves, over 1. Hook them together with a smooth curve, not a point. Put arrows on both ends. So now I have sketched my parabola. Okay? Determine if it has a max or a min. Well, if it opens down, it has a maximum. And it says find the max, that's supposed to say max or min value. Typo. Find the max or min value. Okay? You're looking for the y. Anytime in math they ask you for a value in a problem that's got x's and y's, I said anytime, let's say 99% of the time it wants the y. So what is the y value at that point? It's negative 2. So it has a max. The max value is negative 2. Now it wants to know the domain. Let you in on a secret. All the parabolas we do this year are going to have a domain of all reals. Now in pre-calculus you do parabolas that lay down on their side, they do not have a domain of all reals, but ours do. Now we need to do our range. And I'm going to give you a little poem for the range, and I'm going to go back and write it on the first page. Here was your first page. The range begins at the mins, and the range ends at the max. Okay? Range begins at the mins and ends at the max. Let me explain what I mean by that. Range begins at the mins and ends at the max. Okay, what do I mean by that? This is a max. The range ends there. Okay, so where does the range start? It starts way down here. So my range is negative infinity to negative 2. It ends at the max. Okay, so let's make sure we followed all the instructions. We sketched it. We determined that it had a max. Its maximum value is negative 2. The domain is all the reals from left to right, and the range ends at the max, which is from negative infinity to negative 2. Okay? We did problem 3 in its entirety, and I'll leave that sitting there for a second so that you can make sure yours is good. And I'm going to stop the video, and then when I come back, the next video, we're going to do problem 6.